I have to say that Google is a pretty amazing place, and it is ridiculous the things you can find in there. And this has to be one of the craziest things that I've found. I was searching for a party hat, and lo and behold, one of the top results was a cat celebrating their birthday virtually perfectly for quarantine. And my birthday was a few weeks ago, and that's exactly what I looked like. I had a little sad cupcake in front of a computer, but the cat looks happy, so that's good. And this is actually going to be a great example for us to look at cones and to study what the shape is of the lateral surfaces. So in the last problem, I hope you had a chance to describe the shape of the unfolded party cone or the unrolled party hat, and that would look exactly like this. And now we're going to try to take a little more mathematical approach in describing this shape. So it turns out that this shape mathematically is called a sector. And what that means is that it's a portion of a circle. If we'd extend this curved line all the way around, it'd be one big circle. So if you cut a radius twice, you cut along two of the radii, you're going to get a slice of the circle, and that's a sector. Radius, radius, and arc of the circle. So that is going to allow us to actually find the formula for the surface area or the lateral surface area of a cone, because we know the formula right here for the area of a sector is 1/2 RL, where R is the radius of the sector right here, and L is the arc length of the sector. And since we know that the lateral surface area of a cone is a sector, we just need to figure out what the radius and the arc length are in regards to our cone, and then substitute it into the formula. So down here, I have two figures drawn out here. Figure 1 is the unrolled version of the party hat, and figure 2 is the rolled up version, where we can see it more as a cone. And so we need to figure out A and B from figure 1, what they translate to into figure 2. So question 1 says in figure 1, A is the radius of the sector. You can see it right along this line here. Once we roll up the hat, what is A now? Take our sector, roll it up, and you'll notice that it's now a line from the vertex down to a point on the circle. And it turns out that that is called the slant height of a cone. So the slant height is any line that goes from the vertex to a point in the circle. Now there are a lot of those. We could call this the slant height over here. We could call this the slant height, or the front, or the back. Any of those would be exactly the same as long as you go from the vertex to a point in the circle. So A was the radius and is now the slant height of the cone. Let's check out B. So if B, in question 2 here, B is the arc of this sector, what is B when we roll it up? To do that, I'll show you from this angle. So see that curve and watch what happens when I roll this up. You'll notice that that curved portion now turns into our circular base. You can see it a little more clearly on the party hat that I've already rolled up. See how that is now a perfect circle? So we had a curve before, and now we have a circle. And yes, the actual physical circle isn't there in this party hat, but we can imagine it. And that is what B is in the cone. So we're going to write circumference of the base as it shows in the picture. So with that information, we can now generate or derive the formula for the surface area of a cone. So since we said that B is the circumference of the circle, we're going to try to find that formula first. So hopefully you remember that using R for the radius, the circumference is 2 pi R. You've seen it as pi d sometimes as well, pi times diameter, or it's 2 pi R. So now we can use 2 pi R and S for the slant height to plug into that formula we had for the area of a sector. So, like I said, the area of a sector was 1/2 RL. So now we want the lateral surface area of this cone. We're going to keep 1/2, that's just a number. And then what was R? Well, R was the slant height, and we're calling that S based on this paragraph here. So we're going to do 1/2 times S times what is L? L was the circumference, and we already found that formula. It's 2 pi R. So we'll get 1/2 times S times 2 pi R. But now there's one last step, as I mentioned in this little parenthesis here. It says to substitute the answers in, which we did, and then simplify. You'll notice 1/2 times 2 is just 1, and anything times 1 is itself. So we can actually remove that 1/2 and that 2 and simplify this formula a little bit. So all that's left is S, pi, and R. And we're going to rearrange that to pi rs because you'll generally see it in that order. Sometimes the slant height will be called S. Sometimes you'll see it as L. That's a pretty common one. Or they'll just write slant height. But it's pi times the radius of the base times your slant height. And that's what we're looking for down here in this box, pi rs. So if we submit, it should all be green, and it is. One last note that I've included in this red highlighted section here, that the full formula for the surface area of a cone must include the area of the base, which is a circle, and that's pi r squared. We only found the lateral surface area. So for the total surface area, we're going to have pi r squared plus pi rs. And that would get you the full surface area. But the key here is getting this formula for the lateral surface area because it's not as obvious as the area of the circle down there. Now use that information to look at some real examples of cones and to find the surface area of those cones.